Hello and welcome back. Maybe our discussion about memory was a bit theoretical, even though it was important, but let's see what practice tells us, what research about practice tells us, how to practice in the most effective way, that is. Let's start with something a famous person once said. This is attributed to Franz Liszt, a great composer and piano player. So, if I miss practicing one day, I know it. If I miss 2 days, my friends know it. And if I miss 3 days, the public knows it. And this is to show the importance of studying and practicing. Smith and Bjorg, already since 1992, argued that typical training procedures are far from optimal. They attributed this failure mainly to the fact that trainers failed to discriminate between learning and performance, and trainers tended to presume that superior performance in practice equals, correspondingly, to superior learning. 20 years later, Bain and McGowan, at 2011, wonder, given the overwhelming body of scientific evidence demonstrating the superiority of whole versus part training, it is puzzling that part progression methodologies remain such a popular instruction paradigm. We will see in detail all these technicalities, what they mean, whole, part practice, random practice, etc. Presumably, it is a politically correct stance not to criticize in a published paper the majority of trainers who just try to sell lessons in the name of science. That is, what I say, science of marketing, and not kinesiology, the science of kinesiology. A characteristic of many notions used in motor learning, and not only, is that they exist in opposing pairs with a continuum, scale, in between. Part versus whole practice. Open versus closed skills. Open skills are skills like playing tennis, where the skill changes, or playing the guitar, and closed skills are skills where you do the same thing again and again, like swimming, so you repeat the same movement. Blocked versus random versus variable and invariable practice, which we will see in the next video. Motor versus cognitive skills, specificity of practice versus contextual interference, which again we will see in the next video, and even more. See, for example, Smith and Risberg 2008. Interestingly, even researchers confuse such notions, as Krakauer and Sadmera 2006 notice, when there exists already a gap between research and practice, or science to profession, as Harris notes in 1993. Practitioners contribute to this problem of the gap by refusing to recognize the theoretical nature of science, by not reading widely to compile the necessary evidence for practice, and by demanding simple how-to rules of human movements when these simple answers often do not exist. This is what Nadson notices in 2007. This is why learning methodology cannot be reduced into a series of simple how-to rules. It should be a more complicated model. Of course, not chaotic. Okay, not a chaotic one. In light of the above, a critical presentation of the most important aspects of motor learning that are crucial to the articulation of the model of virtuosity will be attempted here. In motor expertise, that is, expertise related to motor skills, from surgical operations to piano playing, tennis and martial arts, there are virtually no skills that do not employ both hands, bimanual skills, they are called bimanual skills, or both legs, which are called bipedal skills. All of them simultaneously, bipedal and bimanual, or any possible dynamic combination of them. Even in skills that seemingly depend on one arm or one leg, like tennis forehand or taekwondo or a taekwondo kick, In closer examination, all other limbs and even the torso are used as stabilizers, antagonists, previous segments of the kinetic chain, etc. The final outcome is a movement so complicated that can hardly be described, modelized fully in mathematics. On the other hand, expertise in cognitive skills depended heavily on offline motor skills and may be said to relate to the same mechanisms. The substantial characteristic of motor skills is not effector dependency, but corresponding brain functions. Hence, effector dependent motor skills may be improved by means of merely imagining the action, imagery training. In other words, the crucial thing, the crucial characteristic of motor skills is not that I use hands and legs and I move, but it is how I use my brain, specific regions in my brain, and this is exactly the reason why thinking or imagining the movement is so effective in improving the movement. It has been found that learned movement skills consist of some invariant features that do not change, most notably a fundamental timing structure remaining constant when the easily changeable components, which are called surface features, of a skills change. You can find more information about this in Schmidt and Risberg 2008. In their article, Buhusi and Oprizan discuss the possibility that time-scale invariance is an emergent property in a perception with realistic noisy neurons, see dynamic systems theory, rather than being a signature of higher-order cognitive processes or specific computations related to timing, as Schmidt's schema theory predicts. Performers do not only have to produce actions that have the aforementioned structure, but in many cases adjust them in a dynamic environment, which only adds to the degrees of freedom problem we discussed in the previous video. Too many degrees of freedom to deal with, too many possible movements, so to speak. Thus, performers need to both appreciate a situation and respond to it. This appreciation is based usually, but in no way exclusively, on vision and the reaction to the ability of individuals to correctly react. So, some things about vision. Vision is undoubtedly one of the most important senses a performer employs. Exactly because it is so important and because it is taken for granted, both performers and practitioners, teachers, trainers, etc., alike, tend to neglect the significance of other senses, mainly of proprioception and kinesthesis, the way I feel my body. And also they forget to train vision because they consider it as granted, that I don't need to train it, it's there, it's what can I do with that. But there are very important exercises for vision if one searches for them. So, what about responding to challenges? Reaction time is one of the basic human abilities. It is the interval of time that elapses from the sudden presentation of a stimulus to the beginning of a person's response. And this definition is by Schmidt and Risberg 2008. Reaction time is connected with stimulus-response compatibility, which McGillard 2007 informs us that is another parameter that decreases reaction time. The more similar the characteristics of the stimulus and the required response are, the faster reaction time is. For example, if I have to press two buttons quickly, after hearing a voice instructing me right or left, if I have a button that says right and I have to press this button when I hear right, if this button is to my right side, then I will react more quickly than if it's in my left side. So I have to press the button that says right, but it's on my left side, so that takes more time. This is the stimulus response compatibility. Preparation and priming. The second answer to the former question about the ability to cope with a vast number of environmental degrees of freedom is that in case the performer expects the action so as to react with some probability, or when they themselves initiate an action, they engage in a series of preparatory actions which are of major importance and deserve some further discussion. Good preparation is a hallmark of expert performance. Experts' performance advantages are greatly due to advanced preparation and anticipation. And there is also the notion of self-priming, when with my own actions I prepare myself for future actions. Some things about feedback are in order now, because feedback is one of the most important parameters of learning and expert learning. Any teacher with the responsibility to improve motor skills of their performers, motor or cognitive skills for that matter, has two major tools available: instruction and feedback. Guiding the performer's movements by telling him or her what to do. Maybe also, if they know pedagogy, they know the best way to inform the learners. Okay, it's not just instructionalism, just instruct what to do, but anyway. And then conveying useful information about what has been and has not been done. Feedback serves four purposes, namely to inform, to motivate, to reinforce correct behaviors, and to guide, as Edwards 2010 informs us. It can be divided into many categories in relation to when it is given, what kind of information it supplements, how it is given, and who gives it. Like in peer teaching, students give feedback to each other. Sometimes not giving feedback is feedback as well, if this is combined with other forms of feedback. Okay, as we see in the diagram, feedback may be divided into sensory and augmented. Sensory is the intrinsic feedback we have from our own joints and tendons. Some specific organs exist there that give us feedback, like Golgi tendon organs, muscle spindles, and so on. So this is a proprioceptive feedback, that we know how our body feels, and exteroceptive feedback, it's images we take, things we hear, and things that may be felt. So, and we have augmented extrinsic feedback, verbal and non-verbal. So augmented feedback consists mainly of knowledge of results, information about the outcome of the performance, and knowledge of performance, information about the movement characteristics responsible for the outcome, the movement characteristics or the actions responsible for the outcome. These two forms of augmented feedback appear to be beneficial in different instances. As is the case in other instances, the more advanced performance's needs are better served by knowledge of results, and knowledge of performance should help beginners more. For instance, see Edwards 2010. Feedback can also be given in many different ways. For example, there is direct feedback, when after each repetition I give feedback, or summary feedback, where I do the practice for some minutes and then I give a summary feedback of what has been accomplished. The science of pedagogy also is related to feedback and to feedback and instruction, because it is the best way to behave while giving feedback and instruction. So pedagogy does not tell us what feedback to give exactly, but how to behave, for example, when giving feedback. Okay. So let's move on to the next video that we will speak about practicing skills in more detail.